Hi. So for question 4, we've been given an equation of line L1 and we've been told 2 points with which the line L2 passes through, and we've been asked to determine, giving full reasons for our answer, whether the lines L1 and L2 are parallel, perpendicular, or neither. Okay, so I'm just going to give you a brief outline of what I'm going to do. In order to compare both lines to see if they're parallel or perpendicular or neither, I need to find the gradients of both lines. Okay, then I can compare the gradients. If the gradients are the same, we know they're parallel. If the gradients are the negative reciprocal of one another, they're perpendicular. And if they're neither, they're neither. So in order to find the gradient of line L1, I cannot simply just read off as a coefficient of x when the equation is in this form. However, that's a very common error to do. I need to rearrange it into the form y equals mx plus c, and then I can read off as a coefficient of x when the equation is in that form. For the line L2, I'm simply going to substitute my coordinates into this formula here, which you should be familiar with. And if you're not, you can check out the link in the description below. I suggest you watch that first, and then you can come back to this video. So I'm just going to label my coordinates and substitute them into the formula to find the gradient of line L2. And then I can simply compare them and write a statement at the end describing my findings. Okay, so I'm first going to start off by stating the equation of line L1, which is 4y minus 3x equals 10. So what I'm going to do is I'm going to rearrange this to get y. Okay, so I'm going to add 3x on both sides. I can therefore say that 4y equals 3x plus 10. Now I'm going to divide both sides by 4, and I can therefore say that y is equal to 3 over 4x plus 10 over 4. Okay. I can now therefore say that the gradient of line L1 is simply 3 over 4. Okay, so I can read it off as a coefficient of the x term when the equation is in this form here. Okay, now moving on to line L2. What I'm going to do is I'm going to label my coordinates. Here we have x1 and y1, and here we have x2 and y2. Okay, so it's a very common error for students at this point to label the coordinates x1, x2, y1, y2. But you just need to remember that this is an x coordinate and this is a y coordinate. This is also an x coordinate and this is a y coordinate. Okay, but nonetheless a very common error. So I'm going to find the difference in the y coordinates, y2 minus y1, so that's 8 minus minus 1. And that's being divided by the difference in the x coordinates, which is minus 1 minus 5. Okay. 8 minus minus 1 is 8 plus 1, which is 9. And this is being divided by minus 1 minus 5, which is minus 6. Okay, so I can now cancel this fraction. 3 goes into 9 3 times, and 3 goes into 6 2 times. Okay, so the gradient turns out to be minus 3 over 2. Okay, so I can just make a little statement here, and I can say the gradient of line L2 is minus 3 over 2. Okay, so now I can compare the gradients. They're not the same, so the lines are not parallel, and they're not the negative reciprocal of one another, so they're not perpendicular, so they're neither. Okay, so I can just make a statement at the end. And I can say, therefore, by comparing the gradients of line L1 and L2, the lines are neither parallel nor perpendicular. Okay? So that brings us to the end of this question. And if you need help with coordinate geometry or finding the equations of lines, whether they're parallel, perpendicular to one another, you can check out the links in the description below. And don't forget to leave a comment, like and subscribe to the channel. And we'll pick it back up again in question 5. Thank you very much.